All right, in this video, I'm going to take you through part 2 of Objective 1. Remember, Objective 1 was to simplify rational expressions by factoring. We did part 1, taking a rational expression from expanded form to factored form in the previous video. And now part 2 is I'm going to find the excluded values of the irrational expression and then finally write the expression in simplified form. So there's two pieces to this that you have to consider. State the excluded values from the denominator, and we're going to talk about why the denominator in just a second, and then cancel out like factors and write it in simplified form. So let's go ahead and work through this part. I have taken my factored form from the previous video and wrote it over here, and then I'm going to label the initial problem I've been working on. This is expanded form. Expanded form. Because if you remember, if I reference back to our original example, I took something from expanded form here and put it into factored form. Now, that process in part 1 was very, very vital to this whole objective because you have to get it in factored form so that you can state the excluded values of factored form. If you notice here, my denominator, if you notice the relationship, there should be a -1. The relationship between this factor and that number, x can't equal 9, and this factor, and x can't equal -1. So consider that relationship as well. So let's talk about excluded values and what they mean. So for part 3 of this process, I'm going to find the excluded values. And they need to be based off of the factored form over here. That's why this was so important to get it into factored form. Excluded values are numbers that can't be included into the rational expression. So again, if you remember from Module 3, expanded form here, this whole thing, expanded form, and factored form are the same rational expression, just written in different forms. And so there are numbers that can't be included into this rational expression, because if they were to be included, they would make it not exist, or they would make it not work, because now there's a denominator. And if you remember back from grade school, if you divide anything by 0, if you try it on a calculator, 3 divided by 0, or x squared divided by 0, anything divided by 0, this answer does not exist. You can try it on your calculator right now if you want to. It doesn't exist though, and so we have to consider what would make the denominator 0. That would be the question I ask myself after I get it into factored form. In this case, I have 2 factors that exist in factored form in the denominator, and I only care about the denominator because if you had 0 in the numerator, 0 divided by 3, that just equals 0. That's fine. Or 0 divided by x squared, that also just equals 0. So 0 in the numerator is totally fine, but 0 in the denominator doesn't work. So I need to consider what makes my denominator 0. So in this case, this is the first step I would take in this process for this part of this objective. I would look at both factors, 6n and then n plus 9. I would set them both equal to 0 and treat it like you were solving it. Because we need to consider what would I put into this variable n, this n right here, to make that factor 0. And then the same question, what would I put into this n right there to make that factor 0? Because again, if it's 0 in the bottom, that doesn't work. So I have to exclude those numbers from my rational expression. So let's solve the first factor. 6n equals 0. I divide by 6, divide by 6. In this case, n equals 0. So keep that in mind, and I'm going to solve the other one, n plus 9, set that equal to 0. In this, I would have to subtract 9 from the left side, subtract it from the right side. It goes away, so n equals -9. So now I have found, in this case, this process, we've technically just found solutions to a quadratic equation, but because this quadratic equation, this 6n squared plus 54n that turned into this 6n times n plus 9 exists in the denominator, I need to make a very big declaration or clarification that these variables can't equal these numbers. Because if I put 0 in for this n right here and did that math, 6 times 0 times n plus 9, that would make this entire denominator equal to 0. Because 6 times 0 is 0, anything multiplied by 0 is 0. So in that case, that wouldn't work, because 0 can't exist in the denominator. And same thing, if I put, instead of this n, and I put -9, -9 plus 9 is 0. So that would make that one 0, and 0 multiplied by anything is 0. So again, I can't have 0 in the denominator. That's why my excluded values then need to be notified as n can't equal 0, and it can't also equal -9. That is part 3. I have found my excluded values for this denominator of that irrational expression in factored form. Now again, it's always in the denominator, and the factors might look different, but the process is the same. You set the factors equal to 0, and then say that those numbers can't be included in the rational expression because they make the rational expression 0 in the denominator, and that doesn't exist. So finally, that's part 3. Part 4 is to write the rational expression in simplified form. So in this case, I would reference my factored form up here. The process, or the thought process, is canceling out like factors. Like factors meaning they have to be the exact same, or they have to be numbers that can reduce. So I see an n plus 9 up here, and I see an n plus 9 on the bottom. N plus 9 divided by n plus 9, it's the same exact thing. Those cancel out. So I know I will not have an n plus 9 in my simplified form. Now over here, I have a 3 and I have a 6, the whole numbers. 3 divided by 6 reduces to 1/2. And so my final, and this is why you're going to need to practice this and then raise your hand to check your work, because my final answer, if you have questions, please do raise your hand. It's going to be 1/2n, and that's it. With the excluded values of n can't equal 0, -9. This is my final answer. So again, I got 1/2n because this 3 divided by 6 simplified to 1/2. This n here had nothing to cancel out with, so it stays in the bottom where it existed to begin with. And then the n plus 9s cancel out. So I'm left with 1/2 with the n in the denominator. And then n can't equal 0 or -9, and I got that from my factored form. This is the type of answer I need to see to finalize this process. And if you look back to the example I gave you, I took it from number 1, expanded form, here, factored it over here, stated the excluded values by setting these factors equal to 0 and solve. X can't equal 9 or -1 because it would make the denominator 0. And then finally, I simplified it by canceling out like factors. So in this case, the x minus 9s were the same, so I had to cross those out on top and bottom, and I was left with x plus 9 in the numerator, x plus 1 in the denominator. So go ahead and try to finish number 3, steps 3 and 4, and when you're done with that, please raise your hand so I can check your work.